Alright YouTube, welcome back for day 1 of the Blind 75 challenge. In this series we're going through the famous Blind 75 list of LeetCode questions and we're going to solve one per day for 75 days straight. We're starting the series off with what I consider to be the OG of coding interview questions. This one's pretty popular and it's a great easy question to solve, and of course it's called twosome. I've done a whole video on this one before to highlight some of the algorithm runtime analysis results from the brute force solution and the optimal solutions, so let's just dive right into it and make it quick and simple. So let's start off just by going through what the question actually asks. So it says, given an array of integers, nums, and an integer target, return the indices of two numbers so that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So it gives a couple of examples here. So example 1, say we have this array here and we want the target of 9. We're going to return 0 and 1 because, of course, 2 and 7 add up to 9. And then example 2, you can see quite clearly, we want to return the indices that have the numbers that add up to 6. So in this case, 2 and 4, they add up to 6. So we're going to return the index of 1 and the index of 2. And you get the idea. So let's go through the brute force solution. So for the example, let's focus on the number 2, and we're going to check the number 2 against 7, then check it against 11, then check it against 15, until we find two digits that add up to 9. And then if nothing matches 2, we're going to move on to 7, and then we'll check 7 against 11 and then 7 against 15, and you get the idea. So let's start off by instantiating a new integer array, and we're just going to call it result. And we already know that we want it to be the size of 2. Okay, so let's iterate through the array once. So we're going to do for int I equals 0, and we're going to iterate until I is larger than nums.length. And then we're just going to increment I each time we iterate through. Okay, and then we're going to have an inner loop, and we're going to do int j equals I plus 1. We're going to iterate until j grows to be larger than nums.length. And then we're just going to increment j every time we go through this for loop. So from there, we're just going to check if the number at the index of I plus the number at the index of j equals the target. Then we just want to set the resulted index of 0 to I, the result at index 1 to j, and then we just want to return the result. And then finally, if we loop through all of these for loops and we haven't found anything, we're just going to return the result. So this is the brute force solution. Let's run the code here. And we just want to rename the array to match what we've actually been given. And let's run that again. Okay. So basically we can see we have one inner loop and one outer loop. If we think about our runtime analysis, this is quite clearly a big O of n squared algorithm. We obviously want to optimize that. That's not a very optimal solution. So let's think about the optimal solution. How can we make this faster? Well, what we need to do is think about a way that we can track the numbers that we've already come into contact with. That is, in our example of number 1, if we go to 2 and we move on to 7, we want to make sure that we're remembering that we've already looked at 2. That way we can look back, right, and see, can we use 2 to add to 7 to equal 9? The same case for example 2, right? Say we were looking at index 2, which is, the digit there is number 4. And we can look back at the numbers that we've already came into contact with and see that, we do in fact have number 2 in there, and we can use that to add to 4 to equal 6. So how can we keep track of the numbers that we've already been to? Well, we can use a data structure called a hash map to store the results that we've already seen, and then just query that hash map to see if any numbers can be used to add up to the target. So we'll just delete this code here, and we'll keep that result, and we'll start off by instantiating the hash map. So we'll just do map integer, and we'll just call this values. And then we're going to iterate through the array. So we'll just do for int I equals 0 till I grows larger than the length. And we'll increment I on each pass. So the first thing we can do is take the values and just put the number that is at the index of I along with the index. And that will be the default behavior. What we need to do before that is check to see if the map already contains the value that we're looking for. So we'll just do if values.contains key. We're looking for the target minus the value at nums of I. And if the map does contain that key, we found our result. So we're just going to do result at 0 equals to I, and result at 1 equals to values.get target negative nums at I. All right, and then finally we can just break out of this for loop. Let's clean this up a little bit, and we should have reached the end of the for loop. We're just going to return result. So let's fix this real quickly. So, integer is misspelled. All right, there we go. We can see that it's much faster. It's got a runtime now of 0 milliseconds, of course. This is going to be rounded, so it probably doesn't give an accurate depiction of what it's actually taking. But yeah, there we have it. So the first day of the Blind 75 challenge is in the books. We went through twosome, we went through the brute force solution and then the optimal solution. And yeah, day one down. Be sure to like and subscribe to the video if you want to see more of this series. I'll be going through the rest of them all the way from the easy to the medium to the hards, and go through a lot of other data structures as well. So yeah, thanks for watching. Appreciate it, guys, and see you tomorrow.